We will talk about transformations today in the coordinate plane. Specifically, we'll talk about rigid motion transformations. With rigid motion, your shape stays exactly the same size. It won't get bigger or smaller, shrink or grow. When we are writing the points of a transformation, we start out with a normal set of points, so A, B, and C are normal. When we end, they all have a tick mark after their letter, and that's your prime notation, and that tells you that the point is different now. It went through a transformation. The first kind of transformation we'll talk about is a reflection, and what a reflection is it transforms a point or shape across a given line. That is your line of reflection. So as you see, all the points are exactly the same distance from the line of reflection to their prime point. So here to here is the same distance. A happens to be on the line of reflection, and then C to C prime is the same distance. So we'll go over two types of reflections in this video. The first kind is reflecting over a horizontal or vertical line. So horizontal goes across and a vertical line goes up and down. So when you're reflecting across a horizontal or vertical, you just count the distance of the original point, how far away it is from the line of reflection, and then count that same distance on the other side. When you reflect across a line y equals x or y equals negative x, they look like this and that. This is y equals negative x, and this one is y equals x. Those ones are going to give us a formula to follow. So you start with x, y, and then if you reflect over y equals x, you just flip around the points. If you're going over y equals negative x, you start with x, y, and then flip them, but also change the signs. Okay, so we'll do an example of reflecting this shape over the line y equals x. So just so you can see what the line is that you're reflecting over. It's about that. That's the line y equals x. We want our shape to go on the other side of it. So if you folded that, like if you had a piece of paper and you folded it at that line, you would want that reflected shape. So our rule for reflecting across the line y equals x is if you have xy, it will become yx. So let's write down the points that we have. S is at negative 4, 2. So it'll become 2, negative 4. B is at negative 1, negative 1. So that will become negative 1, negative 1. And E is at negative 3, 4. So E prime will be at 4, negative 3. So now we'll plot those prime points. So S prime is at 2, 1, 2, 3, negative 4. E prime is at 4, negative 3. And then B is there. So that is our reflected shape across the line y equals x. So now we'll look at a reflection across the line x equals negative 2. So this line x equals negative 2. A couple different ways you could have learned to graph it. What I usually show students is to make a set of coordinate points, so xy points, where you know that all of your x values will be negative 2. And then you can put whatever you want for your y. The reason you know all the x's are negative 2 is because x equals negative 2. So if I plot those points, negative 2, 1, negative 2, 2, negative 2, 3, the line should create itself like that. So when I reflect across that line, we're going to now count. Whenever it's horizontal or vertical, we can count how far the points are. So P is 1 away, so we'll go 1 on the other side, and that's our P prime. W is 1 away, so we'll go 1 onto the other side, and that's W prime. D is 1, 2, 3 away, so we'll go 3 onto the other side, and that's D prime. So when I connect the points, the blue one is our reflected shape across the line. X equals negative 2. So now we'll talk about rotations. Rotations are also rigid motion because the shape stays exactly the same, but it's just going to turn around. It's going to rotate around a certain point and go at a certain angle, and that's the angle of rotation. So we've got a couple different rules that you can look at to show the rotations. If you have a counterclockwise rotation of 90 degrees, then your original point will become negative y, comma, x. If you have a rotation of 180 degrees, and that doesn't matter which way, because if you go 180 counterclockwise or 180 clockwise, you end at the same position. And that rule is it becomes negative x, comma, negative y. For a clockwise rotation of 90 degrees, which would be the same thing as counterclockwise of 270 degrees, your points become y, comma, negative x. And a rotation of 360, your points would stay the same. So we're going to look at a rotation of 90 degrees, and the point that we're rotating is the point 46. So with these rotations, it's understood that the rotations will be counterclockwise unless it's already stated. So we're going to rotate 90 degrees counterclockwise, and the point that we're rotating is the point 46. So the point 46 is right here. If you want to call that a letter, then you can call it A. So instead of following the rules, I like to do my rotations a little bit differently. I look at the graph and I will rotate the actual graph. So I rotated my graph 90 degrees to the left because that's counterclockwise. And I'm going to look and see where my point is. So my point is now, looking at the graph, is at the coordinates negative 6, comma 4. So that's going to become our A prime. So we will rotate the graph back to face the normal direction. So now the graph is back to the normal direction, and I'm going to plot this A prime point. So if I go to negative 6, positive 4, that's my A prime, and that's where it would land after rotating it 90 degrees counterclockwise. So let's look at another example. I'm looking at the point negative 5, 3. So you can call that a letter if you would like. And we're going to rotate that point 270 degrees, and like I said, if it's not stated, then it's counterclockwise. So we're going to do 3 90-degree turns to the left. And I'm going to turn my graph to face that way. So after I turn my graph, I'm going to look at where that point now is falling. So if I was going to write down what the coordinates would be, so now it's my A prime, it's at 3, 5. So that would be the new coordinates. Now I'll rotate my graph back to the original direction.
Allison.
How are you?
Good, how are you?
I'm pretty good. It's Friday.
Cold enough for you?
Oh, it's freezing. So now that I've rotated my graph back to the normal direction, I can plot this new prime point at 3, 5, and that would be A prime. So that's where it's rotated after a 270-degree rotation counterclockwise.